Welcome to Activity 3.1, Objects that Begin Moving. We're going to start with a quick demonstration. So you're going to use those demonstrations today as you complete Activity 3.1. Our learning target is we're going to use models to figure out whether and how a system begins moving. So we're going to start to take a look at the forces behind each of the two things that you saw in a demonstration. So the expectations for you is you're going to continue to work on developing interaction tables. We've worked with them a couple different times, and you're going to continue to work on creating force models, both for the tennis ball that you saw moving in a demonstration and the marble. So in the video, you saw these two things moving. The tennis ball was tapped by my hand, and the marble was made to move by the rubber band. So it says your teacher demonstrated two simple instances of objects beginning to move: a tennis ball that was tapped and a marble that was shot out by a stretched rubber band. Explain why the objects begin to move. Write a single explanation that is good for both objects. So when you create your response needs to work for both scenarios and not be specific only to the tennis ball or only to the marble. So think about if I got a bowling ball to move, if I got a kickball to move, if I got a book to move, can your explanation answer how any of those objects began to move? So go ahead, pause the video, and create your explanation. And again, you can talk with the people around you, and you can come up with a common explanation if you want. All right. So you've had a chance to create your explanation. And again, your explanation should be something like this. Both objects began moving because a force was applied to them. Again, it's generic enough. How did the tennis ball move? Well, I tapped it. But how did it really move physics-wise? A force was applied to it. How did the marble move? A force was applied to it. So both began to move with a force. So simple definition or simple explanation, it could be applied to any object that begins to move. So what you're going to be doing next is you're going to be creating some tables, and you're going to be creating some interaction tables. So it says, using what you learned in lesson 2, make interaction tables showing all the interactions involved in both cases, and then draw models that show the various components of each system and the forces that act on them and that they apply. So when you're doing this and you look in your book, it can be a bit confusing. So these first two parts right here, you can see it looks like a spot where you would type in. You are. But this is where you're going to create your own interaction tables. Remember, you can choose to create a table column, and you can add rows, you can delete rows, you can add columns. Remember, we worked on doing this earlier to modify a table that was used in lesson 2. So you're going to create two interaction tables, one for the tennis ball that was tapped and one for the marble that was shot from a rubber band. Down below, you'll see two more spots for you to put stuff. These are for drawing. So in one of them, you're going to create a force model. In the other one, you're going to create a force model. You might be saying, two force models. Yep. One for the tennis ball that was tapped and one for the marble that was shot from the rubber band. So go ahead, pause the video. This is probably going to take you 10, 15, 20 minutes to do. All right, so now that you've had a chance to create your interaction table and to create your force model, let's go ahead and answer the questions C, D, and E. So what are the three forces that act on each object? So think about it. And we've kind of practiced doing this already in some previous lessons. So when you talk about each of the interactions, both the tennis ball and the marble, first of all, you got to ask, okay, was the force, was it horizontal or vertical? Was it a push or a pull? Was it a contact or a non-contact force? And then you have to talk about between what two objects. So go ahead and finish C. Make sure you have an answer in your answer. You should have 3 different objects down here, or 3 different bullets or tabs, however you want to arrange them. In each one, you should talk about, for example, it was a horizontal push contact force between whatever the 2 objects were. All right, pause the video a little bit longer if you need some more time. All right, so D says, which of these forces act horizontally and which act vertically? So go back up to C, and it's easy. When you look at C and you answered what are the 3 forces that act on both the tennis ball and the marble, which ones use the word vertical and which ones use the word horizontal, and you're looking for the ones that talk about it being horizontally. Which forces? Then go ahead and look for the word vertical or vertically. Which of those 3, because again, remember you had 3 forces, which ones use the word vertical? And then you're going to put those down here. Now D says which of these forces can cause each object to begin moving. Again, E says which of these 3 forces can cause each object to begin moving. So go ahead, pause the video as you finish D and E. All right, and the last thing we want to cover today is we want to cover the scientific principles. The beginning of motion is always caused by forces, and they have to be unbalanced or unequal. If they're balanced forces, it's not going to cause motion. If the tennis ball was just sitting on the table's pushing back on a tennis ball, and the tennis ball is pushing down on the table, but they're balanced forces, so no motion. You have to have unbalanced forces. In my case, it was me pushing the tennis ball or the rubber band pushing the marble. So hopefully you did well today and you fully understand what's going on. As I go through this lesson, I'm going to check it over, make sure you have full, complete sentences, make sure you have good punctuation, good spelling, and you've tried everything if you want to get credit for it. So what we're going to do now is we're actually going to backtrack a little bit. And now I'm going to go through the answers. And you might be saying, why are you going through the answers right now? Well, because a lot of people don't actually pause the videos. They just go ahead and they copy all the answers down. And then they struggle on tests because they don't know what's going on. So first of all, let's take a look at how you did on the interaction tables. So this is what I would expect to see on the interaction tables. Notice this one is for the marble, this one is for the tennis ball. You could have them, flipped around, that's fine. What are the different components? Well, there's the marble, the table, the rubber band, and the earth. Remember, earth always stands for gravity. With the tennis ball, there was the ball, there was the table, there was the hand. There was no rubber band in that one. Now you might be saying, why is there no hand here? Because you were holding the rubber band. Well, my hand really wasn't involved with it. The rubber band was the force that got the marble going. If we put my hand, are we going to have to put my arm, then my shoulder, my body? So we have to stop someplace. So these are the different components I expect to see on your interaction table. And when it comes to adding the pluses and minuses, Here's the one with the ball. So make sure you have these pluses and minuses correct. And here's the answer key for the marble. So again, they both have the 4. They both have 4 here. They would have pluses and minus signs in them. This is the correct answer I would expect you to have as a correct 3.1. So what would the models look like? They would look like this. We haven't used a circle yet, but you can use any shape. You can use a triangle if it's triangular. So I would use a circle for the ball. If you happen to put it as a square, I'm fine with that. Notice all the forces come in pairs. You have dash lines. You have 2 sets of arrows. You label everything. Again, this is what I'm looking for when I go through it. If your models aren't correct, you're not going to get credit for it. You need to do good quality work, and you need to check your work to make sure it's done right. All right. So again, double check, make sure everything's correct. So what did you get for C? What are the 3 forces that act on each object? Again, you're using each of these. So it's a vertical pull non-contact force between what objects? Well, because of the gravity. So you can say it's a vertical pull non-contact force between the object and the earth. And this applies for both the ball and the marble. What's another one? A vertical push contact force of the table. And if you want to say between the table and the object, that's fine. Both objects are pushing down, so that's why it's vertical. And they're both pushing, and the table's pushing up. And then the third one is, well, it's the force applied by either my hand or the rubber band. So the horizontal push contact force due to the hand or the rubber band on the object. So again, make sure you have these 3 correct. Make sure you make corrections, good spelling, good punctuation, check for grammar, things like that. E, which of these forces act horizontally? Well, again, you just have to go through here and look for horizontal. So it's vertical, horizontal. So I said the push of the hand and the push of the rubber band act horizontally. Which ones act vertically? Well, vertical. So you basically already have the answers. The pull of gravity and the push of the table act vertically. And then we look at E. Which of these forces can cause each object to begin moving? So if I look at E, which of these forces can cause each object to begin moving? Well, the objects begin moving horizontally. Keep in mind, it takes a horizontal force to make them move horizontally. So, which of the forces can cause each object to begin moving? Well, it can't be gravity. Why? Because gravity pulls down, the objects moved horizontally. It can't be the table, because the table pushed up, the objects pushed down in the table. It's vertical. So it has to be this horizontal force. So the objects begin moving horizontally. It takes a horizontal force to make them do so. The push of the hand and the push of the rubber band start the objects moving. Again, why? Horizontal forces cause horizontal motion if they're unbalanced. So again, ask questions if you have them. Make sure everything's done correctly. You have good spelling. You have capital letters. You have punctuation. That way you can get credit for Activity 3.1. Thanks. Bye.